are watching Technical Time.
Hey everyone, welcome to the technical drawing lesson on link mechanism. Link mechanism is a very broad aspect, it's a very wide dimension, and you have things like geogenesis link mechanism, geoclans mechanism, dual spelling mechanism, even something like barcode digging mechanism. But one of the most common and simplest mechanisms you're ever going to come across, either in technical drawing or engineering, is the slider crank mechanism, and it's popularly known for its use in the car engines. Since we've defined the crank and the crankshafts in the previous lesson, I will just go straight to the connecting rods and the pistons. So a connecting rod is a rigid member which connects a piston to a crank or crankshaft in a reciprocating engine. Together with the crank, it forms a simple mechanism that converts reciprocating motion into rotating motion. It can also be used the other way around, that's converting rotating motion into reciprocating motion. The piston, on the other hand, is a device that has a plunging or thrusting motion that goes to and fro.
If you wonder why there's a question at this point of the tutorial, we're going with a different approach. That's the questions approach. In the course of solving this question, we get acquainted with processes needed in solving other slider crank related mechanisms. So the diagram below shows a link mechanism. The crank BC rotates about a center B in an anti-clockwise direction. It's also pin jointed, that's freely joined to a rod CI at point C. Point I on the rod is constricted to slide along the fixed path, that's the line between points A and E. And the length of the crank BC is 30 mm, length of sliding path AE is 85 mm, and length of the connecting rod CI is 100 mm. We have traced the locus of G on the rod for a complete, that's the full revolution of crank BC. The distance between C and D is 50 mm.
And this is how it works. When the crank revolves in the direction of the slide, it pushes the connecting rod forward, and the other end of the rod attached to the slide moves forward along the sliding path due to the motion it receives. When the crank revolves past the slide and is set to return and complete its full revolution, that's 360 degrees, it moves away from the slide, dragging the connecting rod by its attached end. The drag on that attached end of the rod, of the connecting rod, pulls the rod alongside its other end, that sliding end. Therefore, the sliding end of the rod moves backward along its sliding path in respect to the pulling force. That's due to the pulling force. Drawing the slider crank mechanism. Step 1. You draw the fixed points with their respective distances from one another. 2. You draw the crank to its full length, that's 30 mm based on the question, from its points of revolution, that's point B, in any direction. Step 3. You measure the length of the connecting rod, that's 100 mm, from the free end, that's point C, of the crank to the point it touches the sliding path without exceeding it. Step 4. You mark the required point, that's D, for the locus on the line representing the connecting rod. Step 5. You repeat steps 3 to 4 for various positions of the crank. And step 6, you trace the locus of B using a French curve on appropriate applicable tool. that's the slider crank mechanism and the locus point key. If you need more on link mechanism and other areas on typical drawing, you can stick around for the links. Thanks for watching, guys. If you've learned something new, please feel free to subscribe. It has been Daniel Oyeke, and you have been watching Technical D. Have a good one.
Technical D. There's always a better way to do